Hey everyone, and welcome. Today we're diving into something you might not think about, but it's absolutely critical. How in the world do we get that beautiful, crystal clear 4K video from a security camera all the way through a network and onto a hard drive without the whole system just, grinding to a halt? Well, the answer is all about the clever tricks of video compression, and we're going to pull back the curtain on all of them. First things first, let's just wrap our heads around the size of the problem. A single, totally raw 4K video camera is pumping out a mind-boggling 4 gigabits of data every single second. Just try to imagine storing that, let alone trying to send it anywhere. It is a tidal wave of information.
And this right here, this shows you the core problem perfectly. I like to call it the pipe problem. Think about it. Your raw video is a massive 4 gigabit per second flood of water. But your standard network cable, that's just a tiny 1 gigabit per second pipe. You literally can't force 4 gallons of water into a 1-gallon jug all at once. It just doesn't work.
So that's the big mystery, right? If the data is way too big for the pipe, how do these security systems pull it off so flawlessly? Well, it's not magic. It's a whole series of incredibly smart compression techniques that shrink that video down to a size that's actually manageable. Okay, the very first step in this whole process is choosing the right language. You've got to teach the video how to speak in a much, much more efficient way. And that brings us to something called the codec. So what on earth is a codec? Well, the name literally comes from combining coder and decoder. And you should think of it exactly like a language. It's the set of rules, the grammar, that a camera uses to take that giant raw video file, code it into a nice small package, and then let a computer on the other end decode it back into an image you can actually watch. And right away, this brings us to a really critical choice. On one hand, you've got H.264. It's the old workhorse. It's compatible with pretty much everything, but yeah, it's not very efficient. On the other hand, you have the modern H.265, which is an incredible 50% more efficient. A video file that used to be 4 megabytes is now only 2. That's amazing. But there's a big catch. And this is what the experts call the H.265 Trap. See, all that incredible efficiency comes at a price. It takes a whole lot more processing power to unpack or decode that super compressed video. And this has some really serious real-world consequences. Picture this scenario, because it explains it perfectly. Your security guard is sitting at a standard office PC, and you try to pull up 16 of these super efficient H.265 camera streams at the same time. What happens? That computer's processor just goes into overdrive, hits 100%, and the entire system will either lag like crazy or just crash completely. The efficiency you gained at the camera is totally lost at the viewer's desk. All right, so after we've picked a language, our codec, the next puzzle piece is managing the data flow. It's all about controlling the conversation, which brings us to another choice between two main strategies, CBR and VBR. On one side, you have CBR, or constant bit rate. This one is all about being predictable. You're basically telling the camera, hey, never send more than 4 megabits per second. I don't care what's happening. That's the limit. And this is great for calculating exactly how much hard drive space you'll need. On the other side, there's VBR, or variable bit rate, which is all about quality. You tell it, just maintain this level of image quality and use whatever data you need to make it happen. But just like with H.265, CBR has its own trap. Imagine a car speeding through the parking lot. Now, to capture that detail, the license plate, the driver, the camera might need, say, 10 megabits of data for that 1 second. But you've locked it down at 4. So what does the camera do? It starts throwing detail away. The image gets blurry, it gets blocky, right at the most critical moment when you need to see what's happening. So what's the solution? Well, this is the pro move. Professionals often choose a hybrid approach called MBR, which stands for maximum bit rate. It pretty much acts like VBR, using less data when the scene is quiet, but it has a safety cap. This ceiling lets the data rate spike up when there's an emergency, so you capture that critical detail, but it prevents it from ever overwhelming your network. It really is the best of both worlds. Okay, now we get to the really, really clever part. Beyond the basic language and flow control, there's another layer of intelligence that camera makers have added. This is kind of the secret sauce of modern compression: smart codecs. Now, every major manufacturer has their own fancy marketing name for this stuff. You'll see Zipstream, WiseStream, Smart Coding, you name it. But don't let all those different names fool you. Under the hood, they all work on the same brilliant principle. Here's how it works, broken down really simply. First, the camera's little brain analyzes the scene in real time. Second, it intelligently figures out what's just the boring static background, like a wall, versus what's a moving object of interest, like a person walking by. And third, and this is the genius part, it selectively applies compression. It heavily squashes the data for the boring wall, but it uses very little compression on the important person, so you keep all that forensic detail right where it counts.
And the result of all this smart thinking is just staggering. By not wasting a single bit of data on the parts of the image that never change, smart codecs can slash your storage and bandwidth needs by up to 80%. That's not just a small saving, that translates directly into saving a massive amount of money on hard drives.
So, let's recap. We've solved the storage problem. We've made the video file incredibly small and super efficient. But there is one final bottleneck in this whole chain, and it brings us right back to that poor security guard just trying to do their job. We have to save the viewer's PC. This is the question that really ties everything together. You've got this beautiful, high-quality, super efficiently compressed 4K video saved on your recorder, ready for evidence. That's great. But how does the guard watch 16 of those streams live without their computer completely melting down, just like we talked about with H.265?
Well, the solution is a really elegant feature called multistreaming. This just means the camera itself is powerful enough to create more than one video stream at the exact same time, and each one can have its own settings for totally different jobs.
And this is where the magic happens. Stream 1 is your main event, the high-quality 4K resolution stream. That one goes straight to the recorder. That's your evidence. But at the same time, the camera is also creating stream 2, which is a much lower quality, maybe 720p stream, and that's the one that gets sent to the security guard's monitor for live viewing. Because, let's be honest, displaying 16 720p streams is a piece of cake for any modern computer. So, you see, the ultimate key to a high-performance system isn't just one single setting. It's about intelligently using all of these tools together. You record the high-quality stream for when it really matters, for evidence, but you view the low-quality stream for smooth, everyday performance. It's all about matching the right stream to the right task. And that really brings us to the final thought. After seeing all these layers of technology, from the language of codecs to bitrate control to smart compression and multi-streaming, it really makes you ask a question about any system. Is it just blindly recording a fire hose of data, or is it recording smart? Thanks for tuning in.